In 13 through 20, we're asked to find the indicated term of the sequence. So when n is a given term, so here we have n equals 15, so we just plug in our 15 for our n into our function. So when a of 15 is equal to n, which is 15, over n, which is 15 plus 1 squared, just copying this formula here. And that simplifies to 15 over 16 squared, which is 15 over 256. So in that section, excuse me, you're doing every other odd from 1 to 25, so wherever that lands in that section. And then going on to 21 to 28, here we're going to write an expression for the nth term of a given sequence. So we have to use some inductive reasoning here, like we did in that very beginning of this page, and find out what that pattern is. So for number 22, what's the pattern? Let's see, what's going on from 3 to 6, 6 to 9, 9 to, actually, I think this is the one I used in my intro, didn't I? Oops. So to find sequences, we actually use this as our example. And what we found is I was adding 3 every time, or when we did if you set this up as a function, it's 1 maps to 3, and 2 maps to 6, 3 maps to 9. This is our n, and this is our an. 4 goes to 12, 5 goes to 15, and if you notice the pattern here, for n goes to 3 times whatever n is. So our expression for the nth term is going to be an equals 3, 7. Oops, not 7, sorry, 3 times n. And then on number 28, we go back to that rule where we had -1 as our alternating, and this time we have to think about which one of these to use. Do we want -1 to the n or -1 to the n plus 1? So let's see, if I start with 1, if I say when n, I'll make this like a t-table here. So when n equals 1, a sub n equals 1/3. That's positive. So I want my general expression to start with a -1. I want the first term to be positive. So I only want the -1 to be when I have an even exponent, like 2, 4, 6, 8. So let's see. So if I use n plus 1 here, then when I plug in a 1, I'll get 2 so that this becomes positive. So then I'll get a positive for my first term. And then when I plug in a 2, then I get a 3 here, which means I'm going to have a negative. So I get a negative of something. So that is good because I want it to be -2/4. So how do I get that 1/3 and 2/4? So I know there's a -1 out in front of something, but what is the pattern in these numbers? Just looking at the numbers now. I already figured out the sign, but how do I figure out how to get those numbers? So it's positive. We did figure out that it's going to be alternating positive, negative, positive, negative, positive by putting that -1 to the exponent of n plus 1. But how do I get the fraction? Well, 1 goes to 1/3, 2 goes to 2/4, 3 goes to 3/5, 4 goes to 4/6. Go ahead and pause the video and see if you can find that pattern and find that general term. What's going to come next? All right, so it looks like I have n in the numerator, right? My first one is 1, and then a 2, and then a 3, 4, 5. So my numerator is n. And denominator also goes up by 1 each time, except that it's starting at 3. So we could do this as n plus 1. Plus 2. It's always 2 more than the numerator. So it looks like, let me just test this, see if that will work. If I plug in n equal 1, I get this. If I plug in n equal 2, I do get this. If I plug in n equal 3, I get this. So check all 5 of those. Those all look good. And that is my expression. Whoops, where's my square? There we go. All right, so that wraps up 9.1.1.